So, as a quick little warm-up, determine the continuity of each graph in interval notation. So this section, talking about continuity, continuous function, and a discontinuous function. And so if I were to look at this first one, would you say that is a continuous function or a discontinuous function? Brandon, what do you think? Continuous. Why? What defines a continuous function, or what? Okay, so it's still continuing down. What about if I put x? This is a parabola. Suppose I put an x value of 0 into this function. What will I get? Yeah. So we know these just represent coordinates. Like if I were to put in 2, I would get, looks like a -2. If I were to put in 3, I'd get down here at about -5. What if I put 0 in? Would I? Well, let me go any bigger. What's going on right here? Okay. This open circle is saying that it is not defined there. Okay, I'm not picking on you, but being able to look at the graph, there is actually an open circle, meaning it is not defined. If I were to put x in there, I don't get 2. If I put in 0.1, I would get approximately 2. If I put in -0.1, I'd get approximately 2. But directly at 0, it is not continuous. Okay, so by that hole in our graph. So we're going to write the answer, though, in interval notation. Okay, in interval notation, we're talking about the possible x's. And so because it has that arrow, I know I can go all the way out to -infinity, and I will get some y value. But then I'm going to go all the way up to 0 with a parenthesis, because at 0, it is not defined. I'd put a bracket if it was defined at 0. But then I also can go from 0 with a parenthesis all the way to +infinity. And because I have 2 intervals, I'm going to connect them with that U symbol, that union, unite those symbols, or those sets of parentheses, those intervals together. So this function is continuous everywhere except at 0, because I have that open hole there on my curve. Okay, the second one is W shape. All right, so we can kind of look at that one. We can see that there is not any open holes on this one. This one is solid, and it has these arrows continuing on to -infinity and +infinity. So this one, oh, this one, I'll go back to it. This one is discontinuous, and this one is continuous. In my interval, my interval is -infinity all the way to +infinity. And again, that's talking about x values. My interval, if I'm reading it left to right, I'm only worried about the x's. I'm not worried about the y's. So that's not a coordinate. That's an interval that we're working with. So your math Excel, you're going to have some questions about continuity based on graphs, or they might just give you a function and you have to graph it. I don't remember exactly what the problems are in math Excel, but say you have a fraction. Say you had some 5 over x was your function. Well, we know that is continuous everywhere except at 0. We can't have 0 in the denominator. We could have a function that looks like a square root symbol. And we know we cannot have negatives under our square root symbol. We're only working with real numbers. We're not working with imaginary numbers. Okay, so that function would be limited on what values we could have. Okay, and if they did any sort of combination of a square root with a fraction inside of it or anything, so those are common functions that those do create discontinuities. Simple quadratics generally do not have any discontinuities unless they were to give you a graph and for some reason it's not going to be defined at 0. So you're either going to be given a graph or they might give you just the function. All right, so let's go over the basic functions that you should know. And these are just, and these ones you've all seen before, but now at a point, whenever you see this, you already have an idea in your mind what it looks like. So if this says f of x equals x, so f of x is just function notation. You could think of it in your mind as y equals, because we always graph as a y equals. So it's f of x is the function. So it says the function in terms of x is x. Or you can think of it as y equals x. Well, if we did a simple 2-column chart, I know if I'm at -5, my y output also has to be -5. All right, this is the identity function. If I'm at x is 0, y has to be 0. If x is 15, y has to be 15. So whatever I put in for x, that's what I get for y. And that will be that diagonal that's splitting up your first quadrant and your third quadrant. Splitting it directly in half. If we were to talk domain and range of this one, we know our domain, again, the x values would be all real numbers. I could put anything in there. And then my range, the y values, would also be all real numbers. There is not any limitations on this one. It's going to continue on to infinity and negative infinity horizontally, but also vertically. Okay, if we have a squared function, and this is a quadratic, anything degree 2 is a quadratic. So again, you could treat this as just y equals x squared. So I can make a quick little 2-column chart. I can say, okay, if x was -5, that's not that big. Let's go like -2. Y then would be a +4. If I'm at 0, I end up with 0 as an output. If I'm at a +2, I also end up with 4 as an output. So this creates my parabola here. So 2, 4, and 2, 4. It looks like this. So an x squared function we know is a parabola, and the only thing it's going to be is either up or down. We're not going to have any sort of C shape going on. It's going to be a U shape either up or down, and that up or down is dependent on the coefficient on x squared. If it's negative, just means it's going to go down. If it's positive, it's going to go up. And these are all what are called parent functions. These are like the baseline functions. When we start doing x squared plus 5, it changes something. If we do in parentheses x plus 2, quantity in parentheses squared, that changes it up. On this, our domain, again, those x values, I could have any number. But for this parent function of just being x squared, my output is only going to be y values that are greater than or equal to 0. That's specific for this parent function as x squared. If it's negative x squared, it'd be a different range. If there's any other stuff going on with it, I'm talking domain and range for this specific function. Okay, the cubic function. This is another one that you should know, be comfortable with. If you see a cubic, you automatically know in your mind what this one looks like. All right, so again, we can think of it as y equals x cubed. So let's start trying some numbers. If I said like a -2, what is -2 cubed? -8, because -2 cubed just means I have 3 -2's. So -2 times -2 is a +4, but times a third -2 brings it to a -8. So -2, -8 would be a point. I could go -1. So -1 squared would be -1 times -1, which is 1, times another -1, would still leave me at negative. So -1, -1 would be a point. 0, 0 would be a point. If I put in +1, I end up with +1 as an output. If I put in +2, I end up with a +8 as an output. So this is what I mean, that it creates this S shape. If I want to look at domain and range on this one, so my domain, I could put in any real number. In my range, I can get any real number as an output also. Right? Because this will continue to get wider and wider and wider. I could choose a +17 and cube that, and I would get an output. I could choose -150, cube that, and get an output. Okay, but remember, cubics, it's just that number 3 times. And so negatives stay negative. Squares, negatives always turn to positives. But cubics, we can keep the same sign going with it. Okay, and then square root function. So we already talked about square root a little bit on that first slide when we talked about continuity. Well, we know that we cannot have any negative numbers for our x inputs. All right, it's undefined. If I were to say if x is -7, I can't take the square root of -7 in terms of a real number that I can graph. We can't graph imaginary numbers. We can only graph real numbers. So first one I'm going to start at would be 0. Square root of 0 is a number, and it's 0. I could go, let's just go to an easy one. Let's try 4. Square root of 4 is 2. Do another one, let's go 9. Square root of 9 is 3. So this one takes shape like that. So we should know square roots are always going to be in that first quadrant. We can't have any negatives that are going to go left of the y-axis, so that rules out these 2 quadrants. And we're never going to get an answer that is negative, so we're never going to be in this 4th quadrant. So it's always going to be in this first quadrant, but it keeps going on to the right. So on this one, my domain, I want x values that are greater than or equal to 0. Can't have anything less than that. And my range are going to be y values that are greater than or equal to 0. I'll never have a negative y value, and I'll never have a negative x value. And these are all basic functions. These are ones, though, that you should, as soon as you see a square root, you know it's going to take this shape. Now they can change it up, and they can put x -2 under the radical, or they could leave it as square root of x plus 7, and that changes things. This is just the baseline, the parent function, that we have an idea. As soon as we see one, we know what the graph looks like. Cubic function, or I'm sorry, cubic root. So this is the cube root of some number. And so again, we can set this up as y equals the cube root of x. If we want to just continue to work in x and y so we can graph it. So x and y. So this is similar to when we were cubing a number. We took -2, we cubed it, we got a -8. Well, if we were to start here with a -8 and we do the cube root, we end up with -2. So this is our cubic function in reverse. So -1 would end up being -1. 0 would still be there. +1 would be 1. +8 would be 2. So we could graph this. And we see takes the shape, this S shape, but it's on its side now. The last slide, when we had the square root, that was essentially half of a parabola. Because we were limited, we couldn't do a full parabola on it, we were limited. But on this one, we can have some negatives that we're working with. This one, my domain is all real numbers. My range is also all real numbers. That will continue to go up and down as I move further and further out to the right and left. And then also it will keep going. And then last one, absolute value. So this last quiz that we had an absolute value problem. And I asked you to graph it, and I would probably say 90% of you got it wrong because you only graphed a few points and you connected it with a straight line, and that was false. You essentially only had 1/2 of the V shape, and then you just continued it on. Well, it doesn't continue on. That was 1/2 of the V. It actually bounced and went back up the other direction, so we didn't test enough points. And so we'll set this as y equals. And so now I can pick any value that I want. Let's start out with some negatives. Let's say -5. I know -5 is going to become a +5. I could do -2, and that would become +2. 0 would get me an output of 0. So on the test, or on the quiz, most of you got points like this, and then you connected those with a line and extended it down into this first quadrant here. Like I said, probably at least 90% of you did that. Okay? I didn't mark the whole problem wrong. You just got a point or half a point or something off on it. And I drew on there, okay? Keep doing more points. At 2, it would be a +2. So that's where it bounces back up. At 5, it would be a +5. Bounces back up. We know absolute values will not end up being a number that's below the x-axis, meaning it's not a negative output. So we know absolute value in its parent form like this will never dip below the x-axis. I can't get a negative number as an output. There's no number that I can take the absolute value of that gives me a negative. Thing is, if they change this and they said like absolute value of x, let's see, -5 or something, that will shift my entire graph down 5 units. So if they tack on something else like that, yeah, then we're going to go down. But in the basic parent function, it will stay this V shape and it will never dip below the x-axis. We can be right at 0, right at the x-axis, but it's never going to get below. So in this case, our domain is all real numbers. Our range on this one, we're only going to get y values greater than or equal to 0. So these functions, as soon as you see those, you need to make that connection in your head. Okay, yep, I know absolute value takes a V shape. I know a cube root is that S kind of on its side. Because if I ask you to graph one of those, I want you to make sure you choose enough points that I can see the whole shape. If I asked you to graph an absolute value and you gave me a straight line, that's wrong, okay? Doesn't matter if you picked all these points up here and you gave me 25 points all in a line, that still doesn't demonstrate to me that you understand that it's going to be that V shape. So make sure you get both sides of the parabola, both sides of the V shape, both sides of the S shapes, everything completes. Okay? All right, so 2.6 day 1. Tomorrow, we're going to work with piecewise functions, which you have not seen before. Okay, so piecewise functions will be something new. So that's going to be part 2 and 2.6. But this assignment is due Thursday by the start of class.